some unforeseen circumstances. So I'll be taking the interview today. I'm Ishita Bhatia. I'm the Executive Director of STEMM4Girls.
Very nice to meet you, Ishita.
Hi. I'm just waiting for a few more people to join, then I'll start asking you the questions. Okay, I can give everyone a quick introduction about you so that they know. Okay, so Helga Gomes is a biological oceanographer at the Goes-Gomes lab at Columbia University's Lamont Doherty Earth Observatory in New York, USA. She has been studying the advent of an unusual organism, Nautiluca, which has suddenly made its appearance and now proliferates every winter, forming large green phytoplankton as the base of the food chain. This work has generated a lot of attention the world over, and many articles have been written about it. NASA and the NSF have funded them over several years. We're extremely glad to have you here, ma'am, and I think we have a lot of people in the waiting room as well. So would you like to say something before I start the questions?
Oh, I'm very glad to be part of this organization. I had read about it before, but it's such a wonderful and inspiring organization for me. And I'm really glad to be able to answer some of your questions and, of course, to pose some questions to you too.
Okay, great. So my first question to you is, what is your background? What are the subjects you took up during your schooling, your graduation, and further studies?
So I started with an undergrad in chemistry. I started my BSc in chemistry with a minor in botany. And then I moved on to do my master's in microbiology. I wasn't enjoying chemistry as much as I enjoyed having some more biological component to it. So I joined a master's in microbiology. It was a little difficult. The transition was really hard. And after I finished my master's in microbiology, I got into a PhD program. I was a CSR fellow, and I got into a PhD program working in earth sciences, biological oceanography to be precise.
Amazing. Okay, that's great. Those are some really different subjects from the usual.
Yes. It was a tough transition between these two, and I jumped so many fields.
Mm-hmm. So, what are the job opportunities one can do after pursuing a degree in microbiology?
The opportunities are immense, because now you have COVID, so you can see that, there'll be a lot of labs working on vaccines, better, even if we find a vaccine, we need better vaccines, easier vaccines that can be transported and given to people really easily. But of course, we also have other industries like the food industry, which is looking for good, highly proteinaceous, cheap proteinaceous food for people in poor countries, especially. Then we have marine microbiology, where people are looking at new medicines, from bacteria that's found in the oceans. We have this whole field of gut microbiology, where people think that your gut microbiology is what changes how you live, regardless of what you don't need to take medicines if you eat well and have a good gut microbiome. So yeah, there's also astrobiology later, but it's just an immense field, and also bioinformatics, which we always forget about, because you could remember when, I think you were too young, but there was this book, The World is Flat, when the whole world became connected through the internet. This Thomas Friedman wrote this book about the world is flat. And he said that any person who has a good understanding of microbiology, which you can also get through the internet, through doing online courses, you can sit at home and figure out a vaccine for some, simpler disease than COVID may be, but you can play with the amount of DNA and RNA information, proteomics, and all this kind of the information that you have is all free. NIH and all these big organizations, even NASA, gives out all their information for free. So you could be sitting at home if you're smart and doing a ton of bioinformatics and, do what you love doing.
Can I just request everyone to stay on mute so that not distractions in the thank you. Okay, so my next question. So you pursued your degree in National Institute of Oceanography in Goa, right? What did you
Yes.
most enjoy about your time there?
Oh, definitely it was going on cruises with all our friends. So it was really an amazing thing. You had to plan what you were going to do. You have to pack, you have to shop, and then you're all on the cruise, because once you go on a cruise, as my PhD advisor used to say, there is no back door. You can't go to the back shop and buy the things that you forgot. You have to remember everything. So it was amazing. It was fun. We used to order our stuff, pack our stuff, go by train to Cochin, mostly where we used to pick up our ship, sometimes to Voltaire in Andhra. So it was wonderful. Then you plan and then you collect all your data, and sometimes you're working the whole night because the ships are so expensive that if you want to cover a lot of the ocean, the water where you are, you have to keep sampling. So every 3 or 4 hours we stop and we collect water, and we do we process the samples, we analyze them. So there's like no night and day, but it still was fun because we were all young graduate students, and so you can imagine how much fun it was. But also the other part of it is like telling a story that you don't know what's going to happen, what you're going to get, because the ocean is always an unknown. So you bring back your samples, you analyze them, somebody else in another department is saying, no, I don't think you are doing that. That's what we are seeing. We're seeing a completely different picture with our physical oceanography work. And so, bringing those 3, 4 stories together, the chemistry, the biology, and it's such a multidisciplinary field, oceanography. You have to know a little bit of chemistry, physics, and so, then you bring your story together and to write a paper. It was just a wonderful experience for me because it's so multidisciplinary.
Yeah. Okay, so even I'm curious about this question. How did you decide that microbiology was the right choice?
To be honest with you, I could not deal with the dissections. Dissecting frogs in my 12th standard was like torture for me. I didn't like that part. I did like a little the plant part of it I liked, but I always wanted to study I really wanted to do something that was that I did that that I could explore that world of microbes. And I don't know. I think for me, a scientist was at that time without the internet, always looking under the microscope. So I think that was my idea. Like I'd be wearing a lab coat, I'll be doing things that no one can see, and I won't have to touch a frog for the rest of my life.
That's it. Okay, so on to my next question. How did you decide that after your graduation, you wanted to pursue a PhD in earth sciences?
I think that was like maybe coincidence or what, but when I was doing my master's in microbiology, our professor, Marvin Purve, she was from Bombay, and she said, I've got 3 topics, which one do you want? And she had one was on viruses, and I thought, oh my God, this will be I'll have to spend disproportionate amounts of time in the lab, in the pokey lab of ours, and something else, and that was on understanding the bacteria that grow around the mangroves. So I thought, wow, this is wonderful. I think I'll go. So with the help of another person from the National Institute of Observatory, I later went to I collected a lot of samples along the long rivers of Goa. Goa has these beautiful long rivers, and a lot of around those rivers. So I collected those samples, and it was really amazing because of the story I was able to tell about the complex interactions with the mangrove leaves, and how the bacteria live there and depend on the leaf and vice versa. It was such a story to tell. And again, it was so multidisciplinary that I really fell in love with that, with environmental sciences at that time. And I thought that, you know, our rivers are so beautiful and historically have been so important for Goa, for our culture, for everything. And I thought and mangroves are so amazingly interesting. So I think that's what led me to doing my PhD in earth sciences. But I did not pursue this mangrove study. I went into another project which was very biological oceanography. It was deep, you know, big oceans. It was not mangroves, and so I had to put that on a back burner. But I enjoyed that too. Biological oceanography is very interesting, and then I further moved to see how we could study the oceans using satellites, because now, as I told you, oceanography is very, very expensive. Taking an expedition out costs thousands of dollars. And so, but a satellite can tell you, you a snapshot of what is happening in the oceans. And so you can get images every day, and there are a lot of satellites now. So I got into that, and that was able to, led me to work on climate change, because to work on climate change, you need large data, you need big data sets, and you need snapshots and quick stuff. So I was able to, that's when I got interested in climate change, because I was able to work with NASA satellites.
That's amazing. Okay,
Yes.
so you're a master's in microbiology, and so how is it transitioning into something which is so different like earth sciences?
Yes, it was really, really difficult, especially because earth sciences is very multidisciplinary, and I had not taken any classes. So I always had to read what was available, but going on cruises, you are there firsthand, right? So you're looking at the oceans, you're seeing the depth of where's the light penetrating, up to where is there life, all that stuff you could actually see. If you put some kind of an instrument, it tells you the light profile. So you are doing things that are hands-on. So it's just not bookish. So that was, I think, that was a tremendous education for me, because I was doing things hands-on, right? So there I was learning as on the, on the cuff, I was learning so much. I was helping the chemists take their samples. So I was learning some chemistry, physics. And so that, I think, was a good, like a natural classroom for me.
Okay, so how do you think STEM will progress in the coming years?
STEM will progress immensely in the coming years. I think everybody should have a little bit of STEM in their lives, because, it's so important to understanding what is happening in the world. Now, I'm bringing back COVID, because, you need to know what is happening in the world. So that's a huge opportunity for people to understand sciences. But there's also the problem of climate change, which is so huge. You can see now from the fires that are raging in California. We've had 3 hurricanes in the Atlantic at one point, which had never happened before. So STEM, not only studying STEM allows you to, to get a job and to do something that's very interesting, but it also, even if you're not interested in pursuing it as a career, it helps you to learn what is happening in our world, because you need to know, so that you can, ask your leaders, what are they doing? You have to understand the science behind it, even if it's very simple. But yeah, and there are other things like electric cars, which challenges even me. I feel that, I don't know much about it, but solar energy, all these things are so important, going to be so important in our lives and your lives too, because you're going to be here for a long, long time. So, and already you see how the world has changed. The fires that we've had in the West Coast, Portugal is burning everywhere. The climate is changing. So that's, I think, something that STEM everybody should pursue some kind of STEM in their lives and
That's okay. How adversely do you think will climate change affect the oceans, and what is the extent of damage it can cause to marine life?
Oh, for sure. Climate change is already causing a lot of changes in the oceans. In the past, when I was studying during my PhD, oceans were supposed to absorb the carbon dioxide. Now, that was the good part, because everybody was looking at the next to
Like millions of dollars in expeditions to study how much carbon dioxide the oceans will absorb, which is a good thing because then there will be less carbon dioxide in the atmosphere for us. But then they realized the two aspects. One was that the buffering capacity of the oceans was changing, and oceans were getting slightly, the pH was dropping. That's not good for a lot of organisms, especially organisms that have the calcium carbonate shells. There was one aspect, but our study was one of the first ones to show that the marine organ, the food chain was going to change, because instead of having the usual organisms that, the small little diatoms, then they are eaten up by little zooplankton that is eaten up, that whole classic food chain was going to change, because we were seeing this very large organism had taken over the Arabian Sea. You know how many people depend on the Arabian Sea for food, right? About 17 or 20 million, no, much more than that, about 170, I think. People depend. We have huge cities along. People eat the protein from the fish, and so many other things are going on, right? So we know that the food chain in the oceans is really, really important. But then we saw that this organism was growing in huge numbers, and in the oceans, as in on land, it was the conventional wisdom was that plants are plants and animals are animals, and that is so in on land, except for little Venus flytraps and all those things where you animals. But in the oceans, there is this thing called mixotrophy where they do both. And this organism does both. It photosynthesizes, it can get food from light, it can so it has totally revolutionized or short circuited the food chain. So that is a big concern for us. And so that was one of the first, um, our study was one of the first to show how climate change is going to affect the food chain in very drastic ways.
Yeah. Okay, that was very insightful. You spent a lot of time on the ocean. How do you think that changed your life or impacted your life?
It definitely changed my life. It gave me, I wasn't a very adventurous person. I'm not even an adventurous person, but I think that gave me this sense like that you can go out and do things. Then the other part of it was like that learning experience, right? And wanting to, that there's, first of all, when you're on land, you don't think so much about the oceans because, they look the same to you and, you're going on with your life. But then when you are there and you realize the repercussions as well as the importance of the ocean for climate mitigation or for climate change, or even for just, how the food chain is so important, or for and so many other, how a changing ocean can affect us. That I think was really an amazing experience for me. It really changed my mind. And the other thing is, because oceanography is so multidisciplinary and you see like everybody's working, doing their own thing. As I said, the chemists are collecting this, somebody's collecting that, and then your mind starts becoming multidisciplinary. You think like, you think that everybody else's work is as important as yours because yours depends on them telling their story. So I think that really helped me.
Okay, great. How do you think, what were some of the most significant hurdles that you faced in your journey?
First of all, at that time, there weren't that many opportunities. First of all, we didn't have so I don't know if I faced like significant burdens being a woman or anything like that. I think I got my fair chance in doing things. And I didn't think that in that respect, I don't think I faced many challenges. I think that in India, I got the opportunities that I tried to get. But as a woman, I think that it's a little bit used to be unusual for women to be in these fields. So like people will tell you, why are you doing that? You know, that brings you down a little bit. And even when I came here to Columbia University to work at this organization called Lamont Doherty, which is supposed to be, which has pioneered climate change. The scientist, Wally Brooker, who worked there, invented the word climate change. But they were asked to hire women because there were no women. The NASA and NSF, the biggest funding agencies, said, you are not abiding by exactly by, you know, gender equality acts or whatever. You need to hire women. At that time, there were no women even in these type of organizations. So I think that how people perceived you is a little bit challenging. But I think that now we have almost, I think, 60 to 70% of our graduate students are women, and a lot of them are working in geology and geophysics. And so I think times have changed, and they certainly have in India. You have nothing to worry about.
Yeah, and the ratios are slowly getting better in every field.
Yes, yes. Because if I go back to my place of work where I used to work, where there was one woman geologist, one, Pratima, I forgot her name now, but she had come from Delhi. There was one woman geologist. There was, I think, one woman physicist who is still, she's in Canada now, Shubha Satyendranath. And now the whole place is so full of women. It is amazing to see.
It's truly amazing.
Yes.
Okay, so do you see the usage of underwater robots expanding further in the future? And if so, what fields would the research impact the most?
I was thinking that that's really an interesting question. I really like that question. And yes, I think underwater robots, first of all, will be, because robotics itself is changing so much in leaps and bounds, right? The field has gone beyond what I even imagine it to be, and artificial intelligence, everything. And so I think that robots, already I heard that another laboratory in California, Monterey Bay Aquarium, is using robots to go and collect samples and do eDNA analysis of organisms. So you can, you know, go to places where it was very, very hard to go, like hydrothermal vents or deep sea where the pressure is so high, and they're picking up those samples and they're doing the DNA analysis quickly and letting you know what's out there. Then for mining, because when I was in India, we mapped the entire bed of the Arabian Sea and found that it had all these huge manganese nodules, which have got a ton of important chemicals in small micro quantities, but huge. It's a huge resource. But to mine them by using conventional methods is very, very expensive. That could be a possibility. Also to find, you know, gas seeps, gas hydrates, and, you know, where people, it will be so much cheaper to go and explore what's out there.
Okay. So what do you say about the hydrothermal vents as a means to beginning of life? And what implications does it have on Mars, since we've discovered a ton of evidence backing up the existence of oceans on Mars?
Yes. So I think for a long time now, NASA has an actually astrobiology program where they do research, and they also fund research on extreme life, extreme organisms, you know, organisms that can stand, like thermophiles that can you know, live in temperatures that are like 135 to 150 degrees centigrade, in very strange, under very drastic pH ranges. Also, I think pH and salinity. So very high salinity ranges, but thermophiles are known to have, you know, at a time when this planet was volcanic and very hot, you know, millions of years ago, thermophiles were already found there. So the idea is that they might have had been the origin of life. So that thermophiles might have been the first ones to, to produce life on Earth. So if we know these organisms well, if we know them, if we go deep down and study these in the hydrothermal vents, where I think it was only in 1975 that people found these that there was bacteria in these hydrothermal vents where temperatures and pressure was immense, and it was a huge shock for them to find these type of organisms there. And they were like, how can these things grow there? And finally they understood that they are chemosynthesizers. They don't need light. They can break down hydrogen sulfide and use that energy to grow. And of course, there were other chemosynthetic pathways that they also recognized as as being important for their survival. So using that, they studied that, and they've already seen that these type of conditions are already a way. I think they are also being seen in one of the moons of Neptune and also in Mars. And so if studying these unusual extremophiles can give us give us a heads up as to what's happening in the on other planets, because now we have exploration to Mars, to Venus. And so I think yesterday you posted this really cool thing about the gas that they found on Venus on Instagram. That's how I came to know about it. Yeah. So I think that the field of astrobiology is going parallel to the field of exploration of other planets and moons.
Okay, so this will be my last question to you, and then the floor is open for other people to ask questions. So you can type in your question in the chat box, or you can raise your hand and I'll allow you to unmute yourself. So is there any final piece of advice, ma'am, that you would like to give us budding girls and boys in STEM?
Yes, I think that first of all, I know that all of you are interested in STEM. That's why you're here. So I don't have to tell you. I know you love science and you love math. But I think one thing that I always think about is when I was studying, the difference between how schools are geared here versus how we used to be, our schools used to be, handled, was that no one really asked us, what do you think? Because there was so much to study, we had to finish that, and how much stuff is packed into our schedules. So I was thinking about it. So if the teachers don't ask you, what do you think? How about young, smart people like you guys asking adults, what do you think, right? Keep going around and asking adults, like, ask your father, what do you think about climate change? What do you think about this? Or why do you think there's a smog in Delhi all the time? So, I think now is the time, because for you guys to engage adults so that they can open their eyes to what's happening around us, to so many problems that all our countries are facing about different issues, whether social or STEM, and engage people like that, engage older people and say, what do you think? Why do you think this is happening? I don't agree with this, but how can we make it better? I think let's flip the scales and ask them what they think rather than the other way around, right? So I think that's what I think you guys should do all over. Ask all your uncles and aunties what they think.
That's true. Okay, so I've received a bunch of questions. So the first one is by Hamza. As an oceanographer, what is your idea about plastic in ocean? How can we stop plastic entering oceans other than trying to reduce the use of plastic? Considering transition from plastic to other environmental friendly material is going to take time.
Yes, that's a new project that we are doing in our lab. We started off by studying microfibers in the clothes. When you wash clothes, you get a ton of those fibers and they all go into the ocean. And we found so many fibers. And we also found a lot of plastics, and even more importantly, a lot of chemicals, especially medicinal, like, medicines that people throw out in the oceans, or that get into the rivers and all that. we were studying the Hudson River, the plastics, the chemicals were adhering to those plastics. And so now you have these, like, like little eco zones where these chemicals are getting stuck. So instead of just getting diluted, they're concentrating on these plastics. So how to solve this problem is, one is using less plastic, getting people to stop using plastics is a big, I think that young people can do that, because I remember last year we had so many interns in our high school interns, and they were like fighting with each other and saying, no, you can't do this, you can't bring plastics. And now then everybody was coming with their little fork or their little spoon. And that's a small effort, but I think it's also good to engage companies, because, and of course, to find other ways. In India, we used to have, like, very rarely did we use plastics in the past. So if we can get back that kind of lifestyle, like, where you don't use plastics, and encourage like small handicrafts and little, in villages where they used to make those plates with leaves, and try to make them in a way that is better or that can be transported easily. I think these, going back to what we were doing, all the amazing things that we used to do, I think that is a great way for India to go forward.
Yeah, agreed. Okay, so Ashwini has raised her hand. Ashwini, do you want to unmute yourself and ask your question?
Yes, ma'am.
Okay.
Hi.
Ma'am.
Hi, Ashwini.
Hi, ma'am. Why the plants grow in deep sea, ma'am? I asking why means it's plenty of water there. The plants are dead, no, ma'am. Why? How to grow it?
Why plants don't grow in the deep ocean? Is that your question?
Why
Yes,
they
ma'am.
don't die? Like, why do they grow in deep sea?
Why do they grow?
Yeah, that's how.
Generally, plants don't grow in the deep sea. They only grow up to maybe in the Arabian Sea, where there is so much of light. They generally grow up to 200, 300 meters where there is light. But around 300 meters, 1% of the light is, that's it. You get, so maybe you can get plant life up to maybe 400. But what we were talking about is bacteria. Plants need light for photosynthesis, but bacteria does not need light.
Ma'am?
Yes.
But red algae can grow till very
Yes.
deep sea, water, right?
Yes.
Because the light is
algae,
able to, yeah.
Yes, because red algae has pigments that can harvest light or collect light in
Phycoerythrin, right? If I'm not wrong. Yeah.
in a little bit. As the light is going down, the spectral quality of the light is changing. So red algae can capture the kind of light that maybe green algae cannot. So, they are the last harvesters of, because as the light is going down, it's being absorbed by water and by other organisms. So at the end of the maybe around 400, 500 meters, you have red algae may be able to capture, only certain kinds of algae can capture that light.
Excuse me. Whether the light travels into the water?
Yes.
Okay, ma'am.
Yes, it travels, and as it's going down, a lot of phytoplankton absorb that light, but also water absorbs some of the spectra. So as it's going down, you get less and less light. That's why it's dark at the bottom of the ocean.
Thank you, ma'am.
I hope that answers the question. Okay, even Himanshi is over here. Himanshi, hi.
Hello, hello. Hi, Helga ma'am. How are you today?
Good. How are you doing?
I'm great, and it's absolutely amazing to see you. So I'm very happy to have you here. Yeah, Ishita, please continue.
Okay, so I was just taking the questions from the audience. So Rajeshri has asked, do you think the existence of tardigrades is possible on Mars or any other planet?
On what? Those
On
little
Mars.
organisms?
Yeah.
I think it's a theory. It's not proven yet, but people are researching upon this. So what is your opinion on it?
But it still needs oxygen, right?
Yeah, it does. But
Right.
Yeah. So I wonder whether it would be able to survive without oxygen. It's an oxygenic organism. It's not like bacteria that can break other compounds and get the energy from. It still needs oxygen.
mm, okay.
Absolutely.
So
But
Adnan
there's
is
no harm in putting them there and seeing what happens.
Yeah.
Okay, so Adnan has asked, with so much industrialization, many species, including the aquatic ones, are on the red list of extinction. Do we have any regulations or plans for this? Because overexploitation is what humans are known for.
Yes, unfortunately, yes. We've just read that about 30 to 40% of the biodiversity on land has been lost, right? And now with global warming, we think that the oceans will have a similar fate because a lot of, first of all, you know what has happened in the Arabian Sea, our work that the organisms are changing. Also because of the warming, the water column, the upper water column where all the photosynthesis and all takes place has become very too stable. That water column doesn't have much nutrients. You know, when you have a plant and you have a potted plant, after some time you have to put some nutrients. So in the ocean, this is the problem. You have the upper water column gets stripped of all its nutrients because there's so much photosynthesis going on. And the only way for that, for nutrients to come to enter the system is when waters get churned. You know, during the monsoons, you have the waters get churned, and so you have a lot of nutrients coming into the upper water column, and that re-energizes the food chain, and you get all that small little things and then big fish. And in Goa, September is like our highlight because we get so much of fish at that time. But now the monsoons are changing, and they're getting, in some parts they're getting weaker, and that water column is stratified, and it's a little bit, you know, it's stratified and it's sitting there on top of a colder water column, a warmer water column, on top of a colder water column, and so there is no injection of nutrients, and so a lot of those organisms cannot grow. That's another finding, that's another study that we did, and that's very, very disturbing, because if there are no nutrients, a lot of the organisms cannot survive. But this particular organism that we are seeing has a very tight nutrient recycling mechanism, and that's why is one reason why it can survive.
Okay, so the next question is from Rachna. She's asking, what's the longest time that you stayed out at the sea?
Oh, I did not tell you all that I went to Antarctica
Wow.
twice.
Wow.
Yes.
That's amazing.
When I was in the US, I went to Antarctica twice, and I think that during that time I stayed more than 2 months on the ship. Most of the time was on the ship, but we went to land too. We went to the US base, which is very, very interesting. It's a huge base with 2,500 people. They have a cafeteria with the most excellent food. There's a barber. There used to be a video rental place because that time there were videos. Then there's two little bars. It's a very, very cool. And there are a lot of labs and people doing work. So we spent 1 week there. And we did some work in the labs, but most of the time we were at sea. And we went we went through some huge glaciers, and we saw penguins, and it was just amazing. It
Wow.
was really an amazing, yes. So I think I must have spent 2, and I also spent a long time studying the Amazon water plume. So I think
Wow.
we were there for about 40 days, also all on sea, but it was not as exciting as being in Antarctica.
Yes. Then the next question is from Amika Patel. Is there any way in which Pacific garbage patch can be cleared out in the coming years? It's only expanding, the Pacific garbage patch.
Yes, I heard, yes, but how will they remove it? I'm not very sure, but I think people are trying to see if they can see plastics using satellites, because plastics may be giving them a signal, and using that to target, to get ships to go there and pick up the garbage. But there's a lot of volunteer effort. I met a man who works for our organization, but he does not only, but it's a really important job. He does a lot of the ship work. He takes care of our ships. And in his free time, he has this other very well-off guy in Miami, and they sit in his boat and they go and they clear, chunks of plastic that are thing. But that's a volunteer effort. I really don't know what the governments are planning to do to clear the plastic, but I think a lot of the efforts, even Europeans are going out to sea and trying to remove plastics from the ocean, as is Japan too.
So Rajeshri has asked another question. What is the significance of Noctiluca?
So Noctiluca is an unusual organism. We have never, when I was working in the Arabian Sea, we had never seen it. It has just sprung up in about 2000. So in the last maybe 10 or 15 years maybe. And the significance of that is that, as I said, the food chain is very, it's very organized. Very small, nutritious organisms are eaten by some smaller organisms, are eaten by something else, and then onwards to fish and larger fish and other organisms. But now Noctiluca is taking over this base of the food chain, and it has a tremendous advantage because one, it does both things. It can fix light and through photosynthesis, and it can use that food for its own, for growth and development. But it also is able to eat little things around it. So it can eat the little things that are competing with it. It can eat. So it takes over the ocean. It has taken over the Omi seas. It's in December, January. We just saw a bloom of Sindhudurg. Yesterday there was a huge bloom, but in winter, and from January up to March, the waters get blanketed with these organisms, and that means that it's very bad because it can short circuit the food chain. Because the problem is none of the other organisms except jellyfish like to eat Noctiluca. So you see, no one eats jellyfish. So now we have a very short, completely useless food chain, because it's Noctiluca and jellyfish.
Right.
So so it's making the other food chain very vulnerable to, being destroyed or destabilized.
Okay. So Disha Garg is raising her hand. Disha, do you want to unmute yourself and ask your question?
Yeah. Hello, ma'am. Good evening.
Hi, Disha.
Hi. So I wanted to ask about the rising sea levels article. So basically, there are a lot of countries, very, very small countries that are like on the verge of extinction due to the rising sea levels, and people also do not like want to relocate because they would be refugees in another country. So what is your take on it? How to save these people? How to save their nationality and all?
Yes, it's totally disastrous. A lot of these countries will not have countries anymore. I kind of remember one country even bought another island because, they don't know what they're going to do. But unfortunately, the sea levels are rising not only in these places, but also in big cities like Mumbai and New York is so vulnerable to rising sea levels. Mumbai will be completely devastated. Venice is like almost will not exist anymore. But these little countries are, of course, much more important because that's all they have. I think the only way we can combat this is to talk about climate change, to talk about why sea level is rising, ask people, and try to get people to understand why carbon dioxide, a buildup of carbon dioxide, not only is very dangerous, and to push for maybe legislation that prevent that in countries like India and all, solar energy could be booming, right? Apparently even in Texas it's booming now, so we could push for solar energy, push for wind energy, and stop this fossil fuel burning of fossil fuels, because it's just destroying the planet now, and it's so clearly, the evidence is so clear that I think that for young people like you should be like, saying this. We want people in our government who believe in climate change, who can push for agendas that are good. And solar energy is such an amazing proposition. And I think if we could send a man to the moon, and India has done so many amazing things in science in the past, how successful we are. We have such great engineers. I think we could probably pioneer this solar energy movement.
Yes, definitely.
And how can we start? How can we start? Like, I believe that change starts from our own home. So,
Yeah.
what are the small steps that we can take in our own home to help environment?
Yeah, you can, first of all, you can say, like, in the past, we used to walk or bike or just, take public transportation. One thing you can ask is, ask your local governments to put better, safer buses. Now people are stuck with 4 cars, 3 cars, because really you can't go anywhere if you don't have good public transportation, right? So that's one thing that we could do. We have a little town in Goa called Panjim, and there was a movement to make Panjim no car zone, and people were like, no, 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 it's not going to happen. And the shopkeepers were like, who's going to come and buy our stuff? But they're mistaken, because we walk a lot in Manhattan, and when you are walking, your tendency is to pop in a shop, right? So that and who wants to go to a shop and try and park your car there? So so walking free zones, good public transportation, I think that would help in such a big way. Because and also trains, having great trains, we can, people can easily go from city to city. So I think things like that, and there's so many other things that we can do. But like, one is my favorite thing, which is solar energy. But public transportation, I hate to drive, so public transportation is like a godsend thing for me, and I think it can really help people.
Yes.
Thank
Absolutely.
you, ma'am.
Okay, so Himanshi, over to you.
Yeah. Okay. So Amika has asked, how will deep sea organisms ever be discovered, especially the organisms which are basically at the base of the ocean where the light cannot penetrate?
Oh, they've already been discovered, no? Because we have these submersibles like Alvin and Shinkai. Japanese have a huge, maybe 2 now. They've had them for the last 10, 20 years, I think, which can go to deep depths, and you sit inside there, and there are these mechanical arms which pull the mud and collect the samples from the oceans. So Woods Hole Oceanographic Center in Massachusetts also has this Alvin, but I think the Japanese have a one that goes to deeper depths, and so French have one. So they're already collecting these organisms, and they've even been able to culture them. But culturing them takes you. Can you imagine creating those exact settings, like that high temperature, high pressure? But they've done that, which is why they have a good advantage in learning what's happening in other planets now.
Absolutely. All right. So Ranan has asked, the world's population is increasing and the increasing population needs to be fed. So my family and many other families eat fish. So basically the demand for fishes has rocketed in the past decade. So it were if it were you, what exactly would you do, in the sense, how exactly would you make this issue sustainable?
Yes, although I'm not a fisheries person, but I think that the most important thing is to fish sustainably, to have good regulations in place, which you don't fish. When they cast their nets, first of all, they take this little baby fish. So so they're destroying a population of, potential fish for the next season. That's one thing. And then that's one big thing. Then also take care of the environment where the fish are living, so that they can have phytoplankton. Most of the fish eat phytoplankton or smaller organisms. So you have to have a healthy ocean for fish to grow. So that's another thing. But sustainable fishing, understanding the cycle of the fish, the entire life cycle. When do they spawn? Where are the eggs? And so, like in the US, when cod was decimated, completely decimated, the fish named cod was decimated. A lot of European fishermen came and finished with the cod. And so now they have all these rules in place. You can only fish at this time of the year. Yes, it might take a little bit of sacrifice, but I think we could do it. We can manage coastal. We should encourage more artisanal fisheries, because now you have these big trawlers coming, digging everything that is there out of the ocean, putting it in bags, throwing what they don't want. That is completely unsustainable fishing, right? They just pick up all the good things that they want. They either throw everything out or they sell it for fertilizer, or I think maybe fodder for some kind. So all that fish is wasted, and people would have eaten that fish.
Yes.
So that sustainable fishing, I think, could make the biggest, impact.
Absolutely. All right. So, Arfa Arshad, you've had your hand raised. Please go ahead and ask ma'am your question.
Hi, thank you. Hi, Helga ma'am.
Hi, Arshad. Arfa, right? Arfa,
Yeah.
yes.
Ma'am, actually, I had one question regarding the Noctiluca, that they are the bioluminescence, I believe, dinoflagellates.
Yes.
Yeah, and they have.
Sorry?
And they have reappeared in the ocean, the Arabic Ocean, I believe. That's what you have been studying about.
Yes.
So their reappearance is it related to the climate change that has taken over Gulf region?
Yes, in the Gulf region, the Noctiluca, these bioluminescent organisms are, almost dinoflagellates are bioluminescent, but they are taken over in many ways. In the past, they could only be seen in winter, but now you find them in summer. But we are also seeing them in summer. Like September is the end of the summer monsoon, and they shouldn't have been there. But yesterday, someone sent us photographs of them. So yes, climate change is a huge part of it, because one, Noctiluca is, the other thing I may have forgotten to mention is that the Arabian Sea is very well known because it has a huge low oxygen zone around 300 to 400 meters. If you go below 300, 400 meters, you have this big body of water between 300 to maybe 2000 or 3000, where there is very little oxygen. It's called hypoxic zone. It's one of the biggest hypoxic zones in the world. One of the reasons is because there is no flushing of waters, as the northern Arabian Sea is blocked by land, right? Himalayas and all.
Yes, yes.
So there's not much flushing of water, and low oxygen water is coming from Antarctica. So the world over, scientists are trying to study this low oxygen zone. And what we have found out is that this low oxygen zone is expanding. One reason is because we don't have good sewage processing plants. Mumbai doesn't have any sewage processing plants. They throw a lot of their sewage into the Arabian Sea. And so that creates more organic matter, which bacteria can feed on and strip the waters of oxygen, right? So there's less oxygen, so that low oxygen zone is expanding now. And Noctiluca has an advantage in that it can photosynthesize at slightly lower oxygen conditions than other organisms. So that gives it a huge advantage. That's one advantage. The other advantage is, I told you, the waters are becoming stratified. So they are becoming, so there's a very stagnant, slightly warmer stagnant water on top of colder water. There's no injection of nutrients. Again, there Noctiluca has an advantage because it has a very tight mechanism of controlling its nutrients. It is a bulbous cell, and in it there are many, many thousands of tiny green cells which photosynthesize. So it's like a little kitchen. They are recycling all whatever they can manage and keeping Noctiluca alive. At the same time, Noctiluca is eating stuff from around it. So this is a climate-driven pattern, because now you have a lot of organic matter. You have the oxygen minimum zone is expanding. Noctiluca can survive in lower oxygen environments, and it can survive the stratified very low nutrient waters that are on the top.
Okay, Mama, one more thing I wanted to ask, that when these Noctiluca, they bloom in the Arabic Ocean, I say, it's also famous for pearl diving and other fisheries. Do they impose a harm on these day-to-day industrial, activities like fishing and pearl diving as well?
Yes, that's an excellent question, because this is the big problem. Although Noctiluca is not a poisonous bloom, like there are some other blooms, the phytoplankton blooms that have got toxins. It doesn't have toxins, but it's in huge numbers, and it blocks all the desalination plants, all these recreational activities like pearl diving. People don't want to go in the water. So Oman is known for its beautiful beaches, and a lot of other tourists from Europe and other Arab countries come. So it is decimating their tourism, their desalination plants, their oil refineries. And so now we have started a decision support tool. We have a model which tells you, based on different conditions that we give it, and based on the satellite inputs that we get from different satellites, we can predict to a certain extent if there might be a Noctiluca bloom. So that's now we are working with them to push for this decision support tool, because truly it is affecting the economy of Oman in a big way.
Thank you, ma'am.
Right.
Thank you so much.
Thank you so much, Arfa. So Santosh has asked, the pattern and durations of seasons that we have known for so long has begun to change. How do you think it's going to affect the marine life?
Oh, in a big way, because we also studied how the monsoons are changing. And in our earlier paper, we showed that the southwest monsoon has strengthened in some ways towards Oman. And that is producing more organic matter and increasing the dead zone at the bottom of the sea. But in the winter monsoon has weakened, because the winter monsoon depends on the snow in the Himalayas. When there's a ton of snow, those very cold winds coming from the Himalayas, they cool the surface of the ocean. When they cool the surface of the ocean, the cold water goes down. It's like putting a ice cube in a glass, right? After some time, through convective mixing, bottom water, deeper waters come to the top. Those deeper waters have nutrients, so that you get all these beautiful blooms of phytoplankton, which helps the fisheries. But now there's less snow over the Himalayan mountains, so the winds that are coming are moist, and they are not as cool as they used to be. So now we don't have that convective mixing, and we have this stratification. So we have less nutrients in the water column, and that is affecting the food chain in a huge way.
Absolutely.
Yeah.
All right, that's okay. So we have Iranian who has asked a very long question. So he's said, in the future, he wants to be an oceanographer, and he wants to prove all the scientists wrong about the part many species are extinct and they don't really search, or they just push all the video clips that prove it. Such a species can be a megalodon. It normally prefers tropical waters. My question is, as many rumors say they exist in the Mariana Trench or the deep parts, recently they discovered the largest bony fish ever known to mankind. We thought it went extinct, but we found it in the deep, that they normally prefer the more warmer waters. But as they adapted to the deep, they have gone through changes. So what if the megalodon went through the same and still exists? What are your thoughts?
I have, this is a complex question, but you are saying that the biodiversity, what scientists think is a loss in biodiversity, may just be adaptation. So we are looking in another place for an organism so we are looking for an organism in place X. It's not there because it has moved to place Y. Is that your question?
Yes, that's his question. He's also asking, how do you think it would have changed? Would it have changed anyhow because it went from X to Y?
We are not seeing that much in phytoplankton, this adaptation. We are, but it's moving. What we are seeing right now with smaller organisms is that they are moving with the with warming ocean. So they're pushing. Like suppose you got a certain type of phytoplankton up to North Carolina because it was warm because of the Gulf Stream. They might be, now you might see them further up north, up to maybe Massachusetts or something like that. That's what we are seeing, that they are expanding their zone in some things. But we are not seeing high adaptation right now, but it's too early to tell because adaptation takes a long time. Although in smaller organisms, it's a little faster, but I don't think that it's going to happen. I'm skeptical about it. Maybe one or two organisms may be able to survive. But look at ocean acidification. We have not seen a lot of adaptation in ocean acidification. We have not seen corals coming back. Corals take so long to, to regenerate. We are not seeing that kind of adaptation. We are not seeing such strong adaptation in other coralline organisms. So I haven't studied that, but I would hope so, but I don't really think it will happen.
All right, okay. So Adnan has asked, ma'am, I'm just curious to know if you have a fish tank. If yes, what kind of fishes do you have?
Unfortunately, no, I don't have a fish tank. I live in a small apartment in New York, and it's a lot of work, and we go out on cruises and on field trips. So who's going to take care of that fish? So no, I wish I had, but I don't.
All right, that's okay.
But it's something to think about in my retirement.
Of course. All right, so this will be the last question. Arfa has asked, NSF has recently funded for algal bloom study. How dangerous and frequent is algal bloom becoming with the passage of time?
Oh my God, it's really a big problem. All these toxic algal blooms that form, and then the sea shellfish eat them, and then people die. And so we've had this huge problem around the Gulf of Mexico, because most of the time algal blooms are because there's sudden spurt of nutrients, mostly from sewage or also from fertilizers, right? So people like to grow. When they grow, big farmers grow stuff, they just add extra nutrients, they add extra fertilizer with the hope that things will be better, but plants can't take up all that stuff, so a lot of it gets thrown into the ocean. So you have another spurt of algal blooms. That is it's a huge battle for oceanographers to study these blooms. And and Noctiluca itself is another bloom. It might not be toxic, but I've already told you about the hundreds of repercussions of this organism to the food chain.
Right. All right. So I think those were all the questions. Thank you so much for coming on our forum. It was an absolute pleasure hosting you. And I hope you had a great time. And thank you for getting up early on a Saturday for doing this. It was amazing.
Oh, I loved it too. It was one of the most fun things I've ever done. It was great meeting all of you. Wonderful. If you're interested in any way to do some study or anything any help that you need, we are there. You have our email and you have my WhatsApp number. Please contact me.
For sure. Anyone wants her details, just let me know. I will give them to you. Please. And thank you so much, ma'am, for being here. It's amazing to see a woman of color come so far, and we can also relate to your experiences because at the end of the day, you're also from India. So it was great.
Yes, that's why it was so fascinating for me to come back and speak to all of you, because it was like being back home. It was wonderful.
Yes, absolutely. All right, so have a great day ahead, and thanks a lot again for coming.
Thanks. Thank you for having me. Bye-bye.
Bye, ma'am.
Bye.
Should I take that thank you card, this thing?
Yeah.
And thanks a lot, guys, for coming here. There were some really interesting questions. You guys were amazing. And remember that the next person that we have is a biochem professor at IISc, which is the Indian Institute of Science. So we will be opening the registration form for that. And thanks a lot for being here. Arfa, you had some really interesting questions. So did Ranin. Ranin and Arfa, I think you need her details. I've already sent a lot of messages on our groups. Just PC me. And
It's raining. It's raining, not raining.
Sorry.
It's raining.
Oh, sorry. Rainan, just PC me on WhatsApp and I will text you her details. And Arfa, same for you. And sorry, Rainan, for calling you Ranin. Sorry. All right. Thanks a lot, guys. It was great having you. You guys can start leaving now.
Thank you.